So this is another Leetcode binary search tree question. It's the kth smallest element in a binary search tree. Well, when this question is presented to you by the interviewer, the first and the naive, I think the brute force approach would be, an approach similar to what we can do in an array if we have given an array and, and we have to find the kth largest element in an array. So maybe if let's say k, so since we have to find the kth smallest element, we can maintain a k size max heap, and as we traverse our you know binary search tree, we can uh, put the elements inside the max heap, and as soon as the length of that max heap exceeds k, we're just going to pop that out. And after we are done traversing our binary tree, the top element of the max heap would be our answer. You can uh, you can easily find that question another, but that's very naive brute force approach, and that is not the optimal approach because we are not using the property of the binary search tree. That is, every element on the left is less than the root element, and every element on the right is greater than the root element. So if you carefully observe, now the next thing is, what kind of traversal do we want to use here? So if you carefully observe here, the in-order traversal of this binary search tree would be, what is the in-order traversal? That means the root is in between. So left, root, right. Okay. So when we do it recursively, what it says, go left, go left, go left, till I found a null. Then I print my root node. Okay, go right, go left, null. Then I print my root node. Then go right, null. I've already printed my root node. Go back, printed my root node. Go back. Okay, print my root node. Then go right, print that root node. Since left and right child are null, so what would be the order of the in-order traversal? 1, 2, 3, 4, right? So we can easily see if we traverse normally this BST in an in-order fashion, so we can easily get a natural order of the elements in ascending order. So let's do something and create our helper. This is our basic approach, and let's say helper, and we'll have of course a root node, right? And then in k, and we won't be returning anything, we just want to get the kth largest element. So either we can create a global variable here, but that is not recommended, and since variables are passed by value, so let's rather create an array of size 2, where I'll tell you why it's size 2. So let's say int res equal to new int of size 2, right? And that's it. So yes, and one more variable that we can keep, you know um, point of no, I mean this 2 would suffice, I think. I'm just solving this question as we go on, so that is how I'll do it in an interview. So think of it as someone giving an interview, and how I'll approach this in an interview question. So next we have our int res array, right? And if let's make this function void, since we don't want to return anyone, we just want to, if root equal to null, we can just return. And let me tell you what this res will store. So res 0th element will store our answer. Let's comment it, will store answer, and res 1 will act as counter variable, right? Let's see now. What we'll do is, as I said, just in order traversal will give us the natural order of elements, that is ascending order. So let's go left. Okay, go left. K will be as it is. This will be as it is. Okay. As soon as we have reached the end, we'll come back. Okay. Then what we'll do? We'll increase, since our res one acted as a counter, right? So what we'll do is res one equals res one plus one, right? Whatever we have stored, we'll just increment it by one, saying, hey, this is the last node, and if it's nothing there, so increment. This is the first smallest element, right? Every time we reach here, we'll be going in an in order traversal, right? If I just write a print statement here, that will give me an in order traversal, right? If you get what I'm saying, I mean, it's pretty basic in order traversal. Okay, common rest. Now, here comes our answer part. If at any given moment, right, our res1 atom incrementing becomes k, right? And that is what we want, kth smallest element. So this res1 will store the like which smallest element is the current root node that we are at, right? If that is the case, then we store our answer equal to root dot val, right? And just return, right? And here we'll call the helper function, and we'll give the root, and we'll also pass the k and our initial res array. After that, we can just return res 0. All right, let's check it out. Hmm, we're getting a okay. I actually wrote that, but I didn't wrote left or right. I had it in my mind, but I didn't write it. So let's see. It should work now. Okay, it is working. For this case, we have 3. Let's see. Let's try to submit it. Okay, we're good to go. So let me explain you one final time. So basically, we are, I mean, using this res so that we don't have to create a global variable, since, our, if I just create a variable here, let's say int a or something, or int res where I want to store my res, even if I do pass that res here, it won't change and update the value since they pass by value. It will remain as it is. That's why I'm using an array where at 0th index I'll store the answer, and at first index it will act as a counter, and I'm calling my recursive function helper, which will help us to traverse the whole BST in an order. And since as we travel the BST in an order, we will get the ascending order of the elements. So we go left, 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 left. Then as the last left reaches and we have null, we return. We increment our value. Hey, we found our first smallest element. Is it equal to k? Then set the value of our answer to that current value and return. If not, go to the right, 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 right. We found a null, we return. Then we go to the left of the right. If that's the second smallest element, it's 1, and so on and so forth. You get my point, right? If we traverse in this manner, we'll get the in order traversal, and hence we can, calculate our answer. So this is using the BST property. So we don't have to traverse the, you know, whole tree, and we can just get the kth element, and we might have to, but it's better than our heap solution. I think that's all.